Today we'll study section 2.4, Biconditional Statements, and there are 4 objectives in this short section. Write the converse of a statement and interpret its validity. Combine statement using if and only if. Read and write truth tables for if and only if. And break down if and only if statements into their original components. I don't think we're going to do every single thing here in these notes, but these are the objectives for the section. So the first definition is that of converse. The converse of an implication if P then Q is the statement if Q then P. The statement P if and only if Q is called a biconditional statement, and it is noted like this in symbolic form. What it means is if P then Q and also if Q then P. So we can combine this statement if P then Q and if Q then P, and if we combine them then we actually get this statement here, P if and only if Q. So here's a simple example. Read these two statements and connect them. Statement 1, x is even. Statement 2, x is divisible by 2. We can clearly see that these mean the same. So how are we going to connect them? S sub 1 of x if and only if s sub 2 of x. So this example will be helpful in building the truth table for P if and only if Q. First line, pretty obvious. Think of an example, for example, x equals 12. Then x is even, it's true. X is divisible by 2, it's true. And therefore, P if and only if Q is true. Now, for the next two lines, one of them is false, and that shouldn't happen. We can't have a number x that is even but not divisible by 2, or divisible by 2 but not even. So, for the next two lines, if P is true and Q is false, then P if and only if Q is false. There's another way to think about this line, and that is to remember that P if and only if Q, as I said, means if P then Q, and also if Q then P. So if we focus on this if P then Q, we saw in the previous section that P being true and Q being false was false. It was the only line that was false actually in the truth table for if P then Q. So automatically this has to be false as well. And likewise we can think in the same way for the third line. If Q is true and P is false, if Q then P is false. So this statement is false as well. Lastly, we can think about it with an example, and we can also think about it using the two separate implications above. With a number, let's pick x equals 27. So x is even is false, x is divisible by 2 is false, and that makes a true statement. If we remember the truth table for the implication in section 2.3, if P then Q for false statements was true, and of course if Q then P from false to false was also acceptable. So here we are, if we think of these two truth tables, the truth table for if P and then Q and the truth table for if Q then P, they would both yield a true value, and therefore it is true. So there are many ways to read P if and only if Q in English, including the one I just said, and also P is a necessary and sufficient condition for Q, or If P then Q and conversely. There are others, of course.